continue from the other video. I just realized we have more question. So I just want to go through these questions a little bit because Dr. Sharon already go over it in class. And I know some of you in here might have missed the class, so I'm just gonna go over it a little bit. So scientific notation. There is a video on Blackboard. It should be underneath video. It's called Power of 10. You can watch that video. So it'll give you like a little kind of like a concept of how these notation works. But basically 10 to the first is 10 by itself, right? 10 to the second is 10 times 10, which is 100, right? And same thing, like 10 to the third is 10 times 10 times 10, which is 1,000, right? And the other way, if you go it backwards, right? Negative 10 to the negative something. Let's do 10 to the negative 2, which means that it is 10. I mean, no, it's not 10. It's 1 over 10 times 10, which is 1 over 100, which is 0.01, right? Yeah. And then if it's 10 to the negative 3, it should be 1 over 10 times 10 times 10, 1 over 1,000 equals 0.001. That's how you that is how the notation works. So it's basically like 10 times 10 by how many times the exponent is. Let me think. Let me think if there's anything else I can show you. So just remember that whenever it's positive, it's 10 times 10. Whenever it's negative, right? 10 to the negative 2, put it in a fraction form with that in the denominator. So 10 times 10. That's just as far as you need to know about this. You don't have to go into detail like why this works and how this works. If you want, I can make a separate videos and they go into more detail about it. But just let me know. But this is as much as you need to know to solve this problem. Okay. So for the first problem, I will make it 10 to the negative to the 6. Let's do 10. No, that's too big. That number is too big. Let's do 10 to the 5th. Right? So it's going to be 10 times 10 times 10 times 10 times 10, right? So the first 10 times 10 will give us 100, right? 100 times 10 give us 1,000. 1,000 times 10 is 10,000, right? 10,000 times 10 is 100,000. And you notice there's 1, 2, 3, 4, 5, 0, and then there's 5 on the exponent. You see where that lines up? Because 10 to the first is 10, 10 to the second is 100 with 2 0. You see the connection right there? So I would leave that right here. I'll clean it up a little bit and leave that as 100,000. Clean it up. Okay, write in scientific notation for 100K. Well, well, so convenient. We just did it. So it is 10 to the 5th, right? 10 to the 5th. Because if you do it 10, 100,000, right? If you look at it, you see 1, 2, 3, 4, 5, 5 zeros. So it's 10 to the 5th. You see where I'm going with this? It's basically looking at the amount of zero, because each zero means you timing 10 one time. Then this one is 10 to the negative 6. I'll do 10 to the negative 4. So same thing as I explained before. So it's 1 over 10 times 10 times 10 times 10, right? So it's 10 times 10 is what? 10 times 10 is 100. And then this one is 1,000. And this one is 10,000, right? So 1 over 10,000 is what? It's 0.0001. See that? And a trick for this is when you look at negative 4, right? That's number 4. When you count after the decimal, it's 1, 2, 3, 4. You see where that number 1 stands at? It stands at exactly the fourth position after the decimal. No matter what number it is, it's gonna be the same. If it's like 10 to the negative 3, it's gonna be 0.001. You see the connection between that negative 3 and 1, 2, 3. Think of it when you negative, you go behind the decimal 3 times. And if it's, positive, it will be, say 5 right there. It goes 1, 2, 3, 4, 5. It would be 1 before that. That's as easy as simple as I can think of a way to explain it. But yeah, that's how I would imagine it as and explain it to other people. You get used to it. The more you do it, the more you get used to it. So it's gonna be 0.0001, right? Or you can do 1 over 10,000, which either way is acceptable. And now this one, as I told you before, is 1 over 100 million. Yeah, 100 million. I was caught there a little bit, but yeah. Um, look at it. Look at 1, 2, 3, 4, 5, 6, 7, 8. Right? 8, and that number 1 is in the ninth position, so it's gonna be 10 to the negative 9. That's how you do it. So see, 1, 2, 3, 4, 5, 6, 7, 8, and number 1 is at the ninth position, so it's 10 times 10 to the negative 9th. The other way I showed you is because it is in decimal place. That's why you count it backwards. But yeah, if you if you ever convert this to, a decimal, it would be 0.000000001. And if you count it, you got 1, 2, 3, 4, 5, 6, 7, 8, 9. See, number 1 is at the ninth position, so it's negative 9. Yeah, it's a lot. I show you two method. Whichever way you feel more comfortable, you can use it. Yeah, that's your own preference. Okay. So for this problem, 10 to the 8 times 10 to the third. So remember when you were doing like x squared times x to the third, x to the third, you would get x to the fifth. It basically is xa times xb equals xa plus b. So in this case, equals x2 plus 3 equals x5. So this is the same concept. Treat 10 as like an x, because you remember you didn't do anything with the x, right? So you keep it the same, 10. And then 8 and 3 is multiplying each other, so 8 plus 3 equals 10 to the 11th. And if you have like 10 to the 5th plus 10 to the 4th, right? 10, 5 plus 4 equals 10 to the 9th. As simple as that. I'll make it a little more organized right here. So 10 to the 8. Nah, it's a little too big. Sorry guys, bear with me for a minute. 10 to the 8th, right? Times 10 to the 3rd equals 10, 8 plus 3. 10, 10 to the 11th. And since the 11th is at the y position right here, we're looking for the exponent, so y equals 11. You see, that's how you do it. Oh shoot, I'm supposed to do it with a different number, but no, I'll just help you with that. Okay, so for this problem, same concept. And you remember multiplication is adding. Then what is division? Subtracting, right? So let's give us an example, right? X to the third, right? Divided by x to the second. We will get x, right? Because x to the third minus 2 is x to the first, right? Or we can see them write it in fraction. It could be something like x to the third over x squared. And then at this, you would know to cancel out, right? 3 minus 2 is 1. So x 3 minus 2 equals x 1. Yeah, it's just the same concept. So generally the formula for this is x m over x n equals x m minus n. So let's do this problem. I would give you guys a problem which is 10 to the 10th dividing by, let's do 10 to the 4th. Why not? Right? So this is m, right? This is n. It would be 10 minus 4 equals 10 to the 6, right? So let's do a real problem. Let's change this number up a little bit. We got 10, too big. 10 to the 6 over 10 to the third equals 10 y. What is our y, right? So we do 10 to the 6 minus, because 6 minus 3, so 6 minus 3 is 10 to the third. And since you're looking for the exponent of 10 over here, 3 is our exponent, so y equals 3. This is just the example, okay? There we go. And that's how you do the exponent. If you still have any question, just let me know. Shoot me a message on GroupMe or email me. We can set up like a meeting and I can go into more detail about these. All right. Exact special 2.3. Okay. So for this problem, again, I would analyze the question they give us first. So they give us tin atom, 50 protons, and 82 neutrons. Whenever they say this, it means that the atom it's neutral, like Sn with no charge. If there's a charge, they would say like Sn with -1, like Sn negative, or Sn2 negative. That's with the charge. Well, they didn't say anything about it, so we know that this atom is neutral, no charge. And then when you think of no charge, you think that the plus charge and the negative charge, like positive and negative, they are the same level, like the same amount. That's why it cancels out. So let's say carbon, right? Carbon has, let's say six proton, right? And then it is a neutral atom. So we know that proton is the charge, and electron, oh man, electron is a negative charge, right? Proton is positive charge, electron is negative charge. Whenever there's one proton, right? One proton, one electron. So 1 plus 1 minus 1 equals 0, right? But if there's two proton and one electron, so 2 plus 2 minus 1, 2 minus 1, right? It will give us a positive charge. So our element is positive 1. So let's say we have 3 proton, right? 3 proton and 5 electron. So it's positive 3 and electron is negative charge, remember? So negative 5 will give us negative 2 charge. Our element will have a negative 2 charge. Let's say carbon with 3 proton, 5 electron. Then it would be C Negative, two negative. That's how you would. That's how you imagine the charge is. And if there's five proton, right? Five. The thing it's gonna be neutral, so it's gonna be zero charge, and carbon is just carbon. That's how you would understand this whole positive negative thing is. It would help you in a long way. Okay. So for tin, this the letters is your um atomic name, the name, the atomic symbol. Yeah, the atomic symbol. So Sn is the symbol for tin, like you can see right there, tin. And then the number to the left, like the bottom number to the left, is the number of proton. The number to the right is the number of neutron. So an atom has, like neutron and proton stay in the middle. So this is neutron. The red one is the neutron, and then the blue one is the proton. It can be any number. It varies. Like it doesn't have to be the same number. It doesn't have to be more or less. It depends on the state of the atom and whatever the atom is. Then surrounding it, there's like an orbit, and the orbit is for the electron surrounding the nucleus. This is the nucleus. Like this whole thing with neutron and proton is the nucleus. And the one orbiting it right here is the electron. Just how you imagine it, right? And then neutron is a neutral charge. Like neutron, neutral, no charge. Doesn't affect the overall charge of the element. And then the number on the top left is the weight, like the weight of the whole atom, the whole element. So Sn 132 means that Sn weighs 132. I think it's called amps, uh, Armstrong, Armstrong or something. I forgot how to pronounce it. But yeah, this atomic weight comes from adding the amount of neutron and the amount of proton. Like these two. Once you add 50 plus 82, you get 132, which is this weight. We disregard the weight of electron because the weight of electron is, I want to say, 1,836 times less than a proton. And I think a neutron is heavier than a proton. So these two are pretty similar in weight. So that's why we can use these for the overall weight, but not the electron. The electron is too light to be considered. We omit it. Okay. So when we look at this problem, it was asking how many electron orbits the nucleus. Since this one is a neutral, because we were talking about it, right? It was a neutral atom. So Sn right here have no charge. And we know that they have 50 proton right here. How many negative charge or electron do we need to balance out the 50 positive charge or proton? So we have 50 proton, right? So 50 plus charge. How many electron do we need? If we have like 5 electron, right? 5 electron, it will be negative 5 plus 50 minus negative 5 is plus 45. It's not neutral. It's way, way, way too positive. So it's gonna be 50. And we want 50 electron. So balance out, right? Negative 50, positive 50, no charge. So tin is neutral. So our answer for this problem is 50 electron. So that's 50. Draw this atom. Okay. Draw this atom. So when they tell you to draw this atom, you don't have to draw like 50 proton in the middle and then 82 neutron in the middle. You can just draw it like this. right? And then you can write plus 450 like proton, right? And then you can do 82 neutron, and on the outside you can do like 50 electron, you know, like negative 50 electron, like don't have to be negative, like 50 electron. Actually, just keep it like that. He would know what it means. He would know how you derive to that answer. But yeah, I know this is a lot. Like this question is a lot, but I want to give you the basics of how they write this number, and from this number, like how do you get a neutral, a negative charge, a positive charge atom? Because I think if you don't do this, it will be hard for you as we go further into the course. So yeah, again, if I don't make any sense, if you have a question at any point, send me a message. We can set up a Zoom meeting like after class or during like class break or anything, and then I can go into more detail about these problems. But I know for for someone who's not a science major, these things are a little too a little overwhelming because there's a lot of like terms, a lot of basic knowledge you gotta learn. But I promise I'll try my best to help you guys get over these. It's not that bad. If you work, if you do more practice on it, you guys will get it. I trust you guys. You guys are amazing. All right. Thank you so much, guys. Have a good weekend.